All right, so welcome to another session of the off class activities, if I'm included. Okay, so previously we ended at arranging the component and defining the board outline. In this session, we are going to start the routing and hopefully complete it. Yeah. Afterwards, we'll move to a lab and then begin the PCB development process. I mean, the actual fabrication. Okay, but then, before we continue, I want to draw attention to something. I made some slight modifications to what we did in the previous lesson. So let me quickly show you what I did, then continue from there. Okay, so let's start with the schematic. In the schematic, what I've done is I've introduced an LED indicator for so that when we put power into the system, it will turn on for us to know that yeah, there is power. That's the only thing I've done. So I use the resistor together with a red LED, okay, on the 5 volt line. So the moment we put in power, the system is turned on, this would come on and they will know that yeah, there is power in the circuit. That is the only thing. But on the PCB side, I actually made some changes. If you followed the previous lecture, realize that these resistors used to be scattered all over, so I organized them, and I also moved the transistor stuff that were in there. I've gathered all of them here. Okay, I think this is better and optimized than the previous. Okay, so if we check the 3D model, 3D view, this is how it looks like now. Okay, so this is what we have right now. And again, this can still be optimized, but then, like I said, I have to get this board ready by evening for the class. So I'm not particularly interested in most of the PCB, proper PCB design stuff, right? And besides, this is not any high tech or like very crucial PCB board to waste so much time on. Okay, I just need a development board to teach, and that's why we are prototyping this. All right, so let's get started. So we're going to start routing. I hope we can do that within 2 hours, and then move to the lab to etch the board. Okay, now before we start routing, remember we are designing a two-layer board, so we have to define the physical board structure. To do that, we can use this edit board setup and then yeah, define some stuff here. So where physical board stack up, yes, we need just two-layer copper. We don't need any impedance control, and the thickness of the board is 1.6. That is okay. That is okay. All right. What I'm going to do is I'm going to pour ground on the top plane. So I'm going to make it a mixed plane, all right, a mixed signal plane. So there can be power, there can be signals. Then the bottom two, I'm going to make it mixed. But then what I'll do is that I'll pour ground on both top and bottom and route the rest of the connections through them. Okay, especially on the bottom side. Now, because I'm going to fabricate this locally, there are certain things I can't do because for instance, I have to be careful about certain routing techniques because when you are locally etching your board, you don't have this kind of plated through holes and stuff. Okay, so a lot of things that are there that you have to be aware of so that you don't do them as if you are going to send your PCB to a fab house for manufacturing. Okay, and as we move on, as we go on, I'll point out some of these things for you to take note of that. Okay, all these things we don't need them. All right. Now, one thing that we have to be particular about is the net classes. Okay. From experience, when you are designing PCB using the etching method, toner transfer method, I realized that it is so painful to work with something below 1 mm, a trace thickness below 1 mm. You begin to have a lot of breaks and then short circuit issues and all that, right? So ideally, I'm going to set the default net to 1 mm. Okay, I've actually done 0.8 mm before. I'm going to set the clearance to 1 mm. Sorry, 0.8 is okay, just that it is not so easy. You end up with some short circuits here and there. Okay, so I think so far 1 mm has been doing a good job for me. And the track width too, I'm going to set it to a minimum of 1 mm. Okay, because here this time we're going to print and manually iron. So if you use too thin tracks, if your track weights are thin, you realize that you have a lot of breaks and you may have to spend so much time patching your thing. So usually I when I'm going to locally print, I set trace width and clearance everything to 1 mm. Then if there is the need to change something, I change it. Now the via size, I'm going to set it to 1.6 because if I mount a via in there, it's going to be a crude way of doing a via. I will need a very good space to solder the via, so I'll set this to 1.8. So even if the what do we call it, the hole diameter is 1, I still have an annular ring radius of about 4 or something, 4 mm to solder, which is okay. And of course, right now I don't have any option for the via size than to make it 1 mm because that's the drill that I have. We will not touch any of the other stuff. So I'm going to only set the net class, if default net class. If there is any other thing, I would set it in real time. All right, so let's get started. Now, the first thing I usually do is to define my make a ground pour. Okay, so I'll define one. Before you do that, select the layer you want to define on. Okay, so I want to define on both copper, the top and bottom, and I want to pour ground. Okay, on both the top and bottom. So the next thing is to draw the polygon along the shape of the board, like I'm doing. Make sure that the polygon does not self intersect. Okay, so just zooming and scrolling if you are using um, a mouse should do the trick. Okay, so I have to come back to fix this. Okay, and then finally we could have actually ended at that end anyway. But let's do that and now come back here to fix it. So this is quite simple. We just have to hold here and move it along like that. Okay, so now all my ground signals should vanish. You can see that I have a copper fill both on the bottom and on top. Okay, on the bottom and on the top I have copper. Okay, and this copper is ground. Okay, so if we look through the board, if you look through the board, you can see that the grounds are already what connected. Is that okay? That is good. So now the next thing, I'll turn off the pour. It is still there, it's just not visible, and start routing. Let me bring up this. So usually I like to route from left to right, or what do you call it? Um, Sensitive signals first, then power, then all this kind of stuff, right? Now, looking at this, you see, I'm going to locally make this board. I have to try as much as possible to make everything connect at the bottom. All my routes should stay at the bottom as much as possible, okay? Because I can't do plated hole to, I mean, have the luxury of doing stuff on the top. So if I'm doing stuff on the top, I have to be careful. Okay, so I'm going to try as much as possible to route almost everything at the bottom. Okay, that means I have to be very judicious with the space. Okay, so let's start with the power. We don't have to worry about ground. You can see that there is no rust net over there. So it means that it's already connected both on the top and on the bottom. Okay, so I'll press Q and edit it. Now the power, I'm going to set it to, let's try 2.5 mm. Okay, I think that's a good thickness. and we connect that. Okay. Okay, now over here we can take from here. Oh no. So from the switch through here to that, okay, and then try this too. Right, so I'm using a very thick line for the power so that I can reduce the impedance. As you can see, I'm routing power. I don't want to pour power on the system, so I'm routing the power. So that's why I'm using very thick traces, and also yeah. Okay. So any place that I could use thicker traces, I will use it as much as possible. Okay, so let's see this part. Yeah, this place needs to be thicker. But I won't be allowed here. So let's set this to 1.8. I think 1.8 should go still. Okay, then I may have to do it 1.5. 1.5. Okay, so 1.5 works. To avoid reflections, I'll just take this off and route everything with 1.5. Okay, right. Yeah, but I'll still keep this big trees over here anyways. Let's get it in the center. Yeah. Okay. Oh, my bad. Remember, I said I'm routing everything on the bottom. Okay, on the bottom. So I can actually select this and change. Oops. Let's just delete, undo everything and move everything to the bottom. Very important. So that means let me swap the layer and pick it again. We go back to 2.5 and then we route that. I think I can even, maybe let's try 3 mm. Yeah, that would be cool. Yeah, 3 mm is better. Then from here uh, through here, yep, unfortunately this is on the top, so yeah, can do something to it. I'll show you. Let's just keep this. Nah, let's set this to 1.5. After all, it's just a cup. Yeah. Okay, now look at something that I'm going to do. I need to push in some VS through here. Okay, so that's what I'll do. Pull this. Uh, Now, if I want to do this, that's going to be problematic. So I'd rather do this. Probably one. Do this and that. Probably two. Do this and that and three. Okay. Then change layer. Instead of bringing this guy here, I'll rather move it here like that. Okay, and then push VS through like that. Okay, I think two would be okay. Get rid of this. So the way I'm going to do this via is this. I'm going to use LED terminals. Okay, I'll drill hole through there, use LED terminal, push an LED terminal through so that it's on the top and bottom. That's a crude view. Okay, so that's what I'm going to do. All right. Uh, Now we switch back to the bottom, and then so from the 5 volts here, Yeah, we still need to go back to the bottom. So let's do that same trick over there. So one and two, okay, and then we switch, set it to 2.5, and then nope, not here. 5 volts, 2.5. We want it on the bottom. Let me just good. So let's see here. Yep, this is okay. Then again, we push VS through. Now this has to be a 5 volt here and another one through here. Okay, great. Now let us clean up a bit. Then we set its caps and caps over it. We're good. Okay. Actually, I mean, when we get the chance, let us set it as big as possible. So 1.5 we do. 1.5, 1.5. Okay. All right. Now let's move energy to this point. So from here through the over here. Now I'm going to pitch this at the center. Start from here to there, from here to there. Okay. Probably let's clean it up a bit. Yep. Okay. So still staying on the bottom, we have one last route over here. Uh, LED. This instead of 1 mm, let's just make it 1.5. Okay, so 1.2 probably. When you have the chance, just make it bigger enough. It won't change anything. Okay. All right. So I think this place is good. What do we have here? We need to move some 12 volts. Okay, so let's bring it with it. Let's bring it with original size. No, original size will be problematic, so let's make it 1.8. Or be stepping it down from the Arduino size. So 12 volts, 1.8 is too much, so 1.5, and that should work for this. Still, okay, 1.3. Okay, I think passing through here would be best. Yeah, very quite close to the outline, but well, I think I'll keep it there. It's much better. Okay, so you can actually move this guy a little bit inwards. In fact, you can move this guy a little bit in to have more space and then delete that. Okay, so let's redraw the trees. Okay, now, yeah, not too close to the pin, not too close to the edge. And then we do that from here. We again do that. Okay. Now, all right, that's okay. That's okay. So I think that would be okay. There is a oh, we actually have to bring the 12 volts to this side too. Okay. So I'm going to tap it from here. Yeah, it gotta go through that place. So let's see. Can we move this? little bit to the side just to give us some room to move the 12 volts. Okay, so from here, yep, yep, that's cool. So that we can come and work with it over here. Let's end it here at this moment. Correct this. Yep, I think I like it. Okay, so this 12 volt actually might be a little bit of a problem, as in where to pass it through. Okay, we may have to jump. Sure, sure, sure. We will jump definitely. Let's pick from here to here, and then actually let's see how far we can go with this. Okay, so let's fix something real quick over here. Group on group. All right, rotate this. Okay. All right, so we bring this to the middle, route it through the middle. Oh, yep, we need to fix this guy too. On group, rotate to have this. All right, so yes, run through, and then again through here. Let's end it at this point first. Okay, I wish I could actually make these trees any much bigger. However, we don't have the luxury of doing that. So for now, let's just keep it. Let's just keep it like that. Okay, so in fact, this one, let me set it to 1.3. Here. Okay, great. And these guys, let's actually move them and move this one so that the bus can actually just, okay, so tap, 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 tap. Okay, I like it this way. We'll do the same for this. First of all, let's ungroup it because there is an outlier. Okay, fix this guy. Okay, I think this one too has an outlier. Fix this one too. Now move it down, move it up, and I want symmetry, so I'm going to group these guys and then make sure group these guys too. Oh no.
So just select the resistors and group them. Okay, so I want this and that to be aligned. Okay, good. I'll do the same for this. So there's that and that. I want them grouped. This, okay, and that should be aligned. Good. Then our 12 volts will run through. Okay, so the 12 volts run through up to this point. And then we need to also take it through the space to this place, and then finally to this place, right? Let's see if we can make it look a bit nicer. Okay, right, right. So from here, and this really needs to get there. So let's probably get it through here to this guy so that this guy will transfer to this identifier here. Let me just put it directly on them. Yeah, I think even here, just put it directly on them and get rid of that. Okay, right. Just trying to make it look nicer. Mhm. Okay, okay, and this side too, let's just drop on all of them. I think that will be all for our 12 volts line. Uh, and let's make this look nicer. Yep. Okay. Now, quickly, let's get the AC done with. I'm going to set this to 3 mm, just in case. I want this to stay away from every other thing as possible. This will be the neutral. Get it much space from the neutral. I would have pushed it here, but nah, that doesn't sound good. Okay, so these are the AC stuff. Okay, everything stays here, and now over here, though, we need just 1.2 or 3 to route this, and that, and that. For the AC control, oh yes, now Mm, I'm going to do something. So look at this. I'll delete this, that's through that up to this point. I'm gonna move it through here, through there to here. Okay. Oh, yep. So that I don't have to, cross for this particular pin. Okay, I think it's okay. So now this, I don't have to cross it. I can easily do that. Okay, 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 okay. All right, so we are done with the AC. Then one thing we should do is to define a keep out zone around the AC. Okay, if I should fail, see that we still have we still have some copper, DC copper around the AC. Okay, so I'm going to avoid that by defining a keep out zone around the AC. So I'll do this and I say I want it on both top and bottom. Okay, keep out tracks. Nah, there should be tracks. There can be VS, there can be parts, but don't put in copper fill. Okay, and let's call this AC zone. Let's call this AC zone. All right, and define, give it some breathing room over here, over there. Yeah, I think this is good. Now, if I refresh the ground port, you see that now we don't have any copper around that. Okay, that ensures maximum isolation around this AC area. Okay, both on the top, on the bottom. We don't have any copper in that vicinity. Okay, good. Right, so let's turn it off again and let's finish routing this part. So here, let's probably set it to 1.5. The 1.5 should do. Yep. And that's okay. All right. And then, so this signal, we need a place to route this signal through. So, well, we'll come to it. GSM RX. Mm, come to it. We'll come to it. Let us route those that are simple to route. So we need this. In fact, looking at the orientation, this will be better. Uh, yep, and then it will be better to rotate this too. Yeah. Okay. So now it's easier to connect like this and tap from here. No, not necessary. Tap from here to here. Oh, just to make it nicer so that the capacitor can have its own line. Yeah, prefer this. Okay, we also need to give power to this guy. Let's bring it in. Okay, let's route this now. Buzzer. Let's see. This is I2C lines, very important signals. So let's deal with them. Okay. What signal? This is an analog signal. Yes, 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 yes. It's important. Hmm. But we will have to jump. Okay. So this is how we're going to jump. Move here, shape that, push it, and move it over the top. And then remember, we are not sending this board from PC for manufacturing, right? So we can't do certain things. We could have connected this directly, but if you do that, you won't be able to solder it at the bottom. So you have to go back to the plane before you connect. So take note of these things, right? You see, by jumping on this, we get to connect these ones directly. Okay, so yeah. Okay, so yep. Let us clear this, guys. Here to here, reducing the number of routes. All those that are easier to route. Let's do that. Okay, great. Can see something fishy going on there. Okay, so we need 5 volts here. We have any closer? No, we don't. Okay, so okay. We could actually let's grab from this. Let's grab from this and jump again. And let us line it up with the previous jump just for aesthetics. And then move 5 volts. Over here, we don't need it for a lot of current heavy duty work. So this trace thickness, I think, is okay. However, well, we could increase it a bit. So you can select all and go to edit and set it to maybe 1.8. 1.5 was actually okay. And let's set it to 1.8. Okay. Now, I want to clean this one a bit. Yep. All right. Still cleaning. Still cleaning. So let's fix this, guys, from here to there. So you see, when you take your time to do proper arrangement, you don't really suffer with the routing. See that so far, things have just been snapping, okay? Just because I took time to arrange the component in a way that it makes it easier to route. Okay, so take note of that. Okay, the ground we don't have any issue. Let's see, 5 volts needed. Let's start from here and create a bus of it. Oops. Okay, from here to there. Uh, which side will be the best to move through? Looking at this, it will be better if we rotate this instead of the other way around, because that saves us a 5 volts cross. Okay, and we can easily route that. Okay, better. Okay, this would go here and go through here. This would go here, go through here. Oh, we gotta jump here. We gotta jump there. We will come to those things, because we have to really pay attention to them. Okay, have to change. One is actually, okay. Yeah, come in. Okay, so over here we are having issue with the clearance, right? So one thing we can do is to quickly go and update our default clearance, set it to zero point 0.8. Okay, that'll give us some room to fix this. Then afterwards, even that one not much. Afterwards, we yeah, still not good, not good, but it's better. Okay, so let's go back to width and set it to 0.7. That should give us enough room to route. Afterwards, you can turn it back to the one. Okay, 0.7. Okay, so now yes, so you can see that now we can easily connect. And let's actually use this opportunity to do for the rest. Okay, and also for this, and also this one wasn't properly connected. Okay, great. So now we can go back and switch it back to one. Okay, so that's a little trick you can do. Okay, great. Definitely we will have to optimize something here, but like I said, let's finish up with the easy ones. What did I do? I think I set the wrong value. Let's go back to the next classes. Yeah, so 1, not 0.1. Right, great. So let's route again from here to there. Yeah, we need 5 volts line here. Can get it from here. That's okay. Yeah, that's okay. Hmm. Blue, green. Yeah, I'll take my time to optimize these things. I have to. So let's finish with trying to finish this in 2 hours. So let's just do those that is it. Okay, so now we can route the LEDs. The LEDs, let's route them on 1.5. See, oh, okay. So we can do 1.5. How about 1.2? Yeah, 1.2 is good. So simple when you get the arrangement right. Okay, so now we continue. Okay. Hmm, here, long cross first. Let's fix this. Hmm, fix that. Okay. Whoa. So this is actually something that runs through. So we can actually tap this from here. So this is actually the points that they connect to the transistor. Yeah, that's the common point. So probably okay, that the size, the dimension is okay. And now we have to do some jumping, definitely, and probably rearrange some of these. Looking at this would be good. It is here. Mm, okay, so let me ungroup this quickly. This, now that we know how they look like, let's put this here, move this here, move that here so that we can avoid crossing LEDs, crossing routes, and then bring this here. Okay. Let's ensure that everything is intact. Great. All right, so this one, for instance, can route it through here. Okay, through here, probably just bend this die a little so that we have space. Now that goes here. Great. We try to avoid crossings as much as possible. Okay, but it looks like over here we don't have any. Uh, oh, actually, we have a fighting chance here. Look at this. I can move this through here, through there, right? Then bend this one a little bit. That gives me the opportunity to route this through this point. Let's clean it up here. Okay, and once I do that, I can get rid of this, that, 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 so that I can connect this here without any problems. Okay, so now this has to be connected to its resistor. We definitely have to cross. Okay, so from this resistor, okay, so yeah, let's bring it in there. Think I wanted to increase the size. This is okay. So we definitely have to cross. So let's see, can we get it any much closer before we cross? Yeah. So let's cross from this point, push a via, and then get out here. Please take note, you are not sending this board to a fabrication house. So there are certain things we can't do, like connecting this point directly to this point. Okay, then you have to solder it on top, which may not, which will not be possible because this LED will have to sit on, okay, on the board. So that's why you have to bring it here and change the layer. Okay, so take note of that. All right. Definitely we have to change these guys too. So again, we move, we find a place to pitch our whatever, and then move it again. Even for resistors, that is not much of a problem. We can actually solder on top. However, I just want to stay consistent, so I'm gonna use the same technique throughout. So I need this to be on the bottom. Okay, great. No, for homemade PCBs, usually you don't get the luxury. In fact, look at this for instance. You have to move it away, because else the LED cannot sit properly. Okay, so let me actually move it a bit further. Okay, further. Yeah, so that the LED can sit properly. And we do the same thing for this guy. Move, we pitch, change, and then at this point we change again and we join. Okay. Yeah. Maybe later we take time and clear some of these things and see how nice they can be. Hmm. First one is better. Okay, so we're done with this guy. But then there is something here. Okay, so this is for that. So the next thing, let's route this. Sometimes you may have to move a component to make it easier to route. If that is possible, just do it. Okay. If that is possible, just do it. Okay, so here, remember we are routing everything on the bottom. Okay, the easy ones first. Always, those that are easy to route, get them out of the way so that you can strategically plan those that are not. Okay. Looking at this, it would be nice to rotate it, but yep, yep, okay, yep. Now move this through to here, and okay, let's straighten it out. All right. What else? Things that could be optimized. Yes, we can optimize this so that we can route this one through here. that. Okay, and yes, so we're going to do the same kind of change to this. Uh, okay, now this should come first, this should go last. Okay, so ungroup this, move this one. Hmm. Yes, so it said this needs to be on this rather. Take care of something real quick. Okay, so we do the swapping, and this definitely gotta come outside to this point right instead of the other guy, and this would, in fact, this has to come here. Then this goes in there. That saves us from swapping, crossing. Yep, this good. Okay, so now you see that the buses are coming out in a parallel form, right? Again, let's ensure that every connection is intact. Okay, and now you can route this around to this point. Okay, anything we have to do to avoid crossing. Okay, and you can easily route this one to here. Okay, and again, we have to jump on this. Just like we did for the other side. Snap out of it and then yes, rounding this up. Okay, we do the same for that. Get it somewhere here, jump, and then move it before we pitch it. We do that. Okay, so let's see if we can space them out a bit. Okay, so yes, oh, there is one more. There is something we have to do here. Of course, we have to jump. So uh, we start from the bottom, then we jump. Okay, and then we come here. Before we pitch it to the pin, we do that. Okay, I think this could be made thick up a bit. It's one, so let's set it to 1.2, 1.5. Okay, all right. So you see that yes, so far we are doing a good job. I expect there would be some issues, but not so many. Okay, because all these things are being done. Oh, okay. So let's change again. Uh, Easy routes first. Okay, easy ones first. Yes, there's one easy guy here. There's another one here. And then we can get another one here. Oh, yeah, we could also route this guy without jumping. Yep, clean it up a bit. Okay, I think this one's not going to be easier like the previous. Yeah, but we can still clear. Okay, so let's do some cleanup on this. I see that we have some crossing, right? This can be routed through here, so it would be ideal if we move this to this point. Move this to this point, and then yes, parallel. This guy needs to come within. So technically, let's move this here, and then this would come here. Okay, so we are doing all this so that we can avoid so many crosses, okay, or many jumps. Okay, now there are certain things that we are doing here because we are going to locally etch this board. If we're going to manufacture it using uh, a professional PCB fab house, we wouldn't have worried about some things we have to worry about now. Okay, so move, can route this across here to there. This can easily move through here. Don't have to jump on it. Okay, and that also gives us an easy access to this. So the only thing we have to jump on would be this. Yes, definitely we have to jump. So let's jump, push and pull. Mm. Now we may have to do multiple jumps at this point. So to avoid that, let's rather route this through that place, through here, and jump over here instead. Okay, when we jump from here, you can just change layer through here and then route on the bottom through here. Good. Okay, let's correct this and probably, yep. All right. So this is better so that we can easily route this guy without jumping over a jump. Can we go like this? Ah, let's go like that. Okay, not bad, not bad. So how do we move this? We definitely gotta jump out, but we already have a jump over here. So tap into it and then just do it once over there. Okay. Yeah. Now we need to hook it up to this, but before we do that, let us route this space. Okay. Route this space. So easy ones first. Easy ones first. Okay. Okay. Any other easy one to route? All right. So this can be routed through here, through there, to this point. Hmm, think this is similar to this, so you can actually uh, not this time probably. Okay, see if we can squeeze some space. Okay, okay. Now, are we still able to move this here through here? I'm afraid not. This time we gotta jump. So, well, let's jump. Move it through here. But then, let's do rearrangement because our arrangement is not optimized. So we better we move this guy here. So from here, okay. Now this will be good when it is here. Let's align it. Let's align it. So now our routes are parallel. So we can easily do that and change over here. Let's clean it up. Okay. Um, we can actually we can route this guy through here. See if we could get some space, or probably pull this one down a bit. Yeah, can straighten this and now route this through this space, to here. Okay. We definitely have to cross with this, but that's okay. We, yeah, we definitely have to cross. Definitely. definitely. But then, uh, yes. So let's just cross. So jump layer. And let's just change back at this point to there, and then this is easy to route, and this one, hmm, actually, let's just jump. Okay. Yes. Yeah, we still have this. Oh, okay. We can actually, yep, grab this from here. So let's bring this to this point, and then move it here so that we can actually tap here through here to there. Okay. All right. Now, are we done? Okay. So this guy, we're not going to waste time with it. We will jump. Just jump. Okay. And I'm going to increase it to 1.5. Okay. I want to change the size. Let's just move through, and change layer over here. Okay. Now let's see if we could. How about we shift it here. Let's fix this. Okay, so if we do that, we could instead route this to here, and that would be good. In fact, let's clean this up, please. To leave this to that. Yeah, that's better. Okay, now we still have something to connect here. We still need to connect this guy. No space to pull it through here. So let's change. Hmm, okay, there isn't space, but we could actually make space, shifting this a little bit down. And I think even by doing this, we can route. Oops. Yeah, let's still move it a little bit down. See if we could. Yep. Yeah. And move this here. Good. So that saves us from jumping. That saves us from jumping. And then let me. All right. Okay. So yes, we left with just the bottom guys. Bottom guys. In fact, this place I think it's not nice. So let's just through this point. Hmm. Now, if I do that, soldering would be will not be nice because now they will all reflow over the entire surface. Okay, so I'm not going to do that, rather do this. Yeah, so that it can flow nicely. Yeah, let's go there. Okay. Do same thing for this guys. Instead of routing it here, I'm gonna pinch it here and then do that. This will make my soldering look cooler. And this same thing here. Well, technically, okay, so this will be under and on top. Hmm. Ah, let's just route. I said there are certain things I am ignoring because I don't want to be wasting time on those stuff. It's just supposed to be something simple and basic and all that. Okay, great. Now we have these greens. Then finally, so we've already spent 1 hour 18 minutes. Yeah, we could still manage to do this in 2 hours. So let's see if we can. Let's see if we can. Hmm, okay. Any easy routes? Yes. Any easy routes? Yes. Any other easy routes? Yes. Move this to here. Move there. To there. Let's go here. And this goes here. This guy will be handling so much current than the rest of the traces in here. So let me just beef it up a bit. Set it to 1.5 instead of 1. Yeah. Okay, now mm, we could actually save ourselves Actually, I can just connect this guy here. No, but if I do, I can't route that. So I'm gonna push through here to here. Okay, so that I can easily route this like that. And okay, yep, we can do this. We can also route this. Okay, so as you can see, uh, some changes have to be made. Swapping this to, okay, move this here, move that there, and bring this back to this place. So that now the routes are parallel. You don't have to cross over there and over there. Okay, that saves us from crossing over. Now here, is there something that could be done? Unfortunately not. So we have to jump, but then we can optimize. You can see there is a crossing over at this point. Well, this cross in this case wouldn't interfere with our job, so we can actually do that. And then change move, and we can do route this. Not okay, this place is okay. Right now, let's clean things up. Okay, and okay, great. Probably this way. Yeah, and finally, not finally, we could just route this one through like that. Okay, now don't forget we made a mistake here. We don't intend to connect directly to, as I have already explained. Okay, great. Now let's finish up with this side and we are almost through. Easy route first on the bottom. Okay. Yep. And we can this through. But that blocks us. So I'm gonna move it through here. Okay. Yes, this is needs catch. Okay. And cool. We gotta optimize this to swap them because they are crossing over. So on group, move this, bring that, and then move this in place. So now they are parallel. We can easily connect this without crossing over. Yes, definitely we got cross over. So we can do the jump here and then return here. Okay. All right. Now over here, hmm, should connect, and then okay. Now this should be optimized too because they are not as it stands. So let's ungroup it, move this here because it can easily connect at this point without jumping over. Zoom in, fix it here. All right, now parallel, parallel. Let's put this back. Okay, everything is intact. Yes. Now we can easily connect this without any jumper. And look at this. We can actually move this one to here to here. And that we can get this to also connect here. And we can get this to actually move without crossing. But this space is too small. Hmm. Okay, so let's sacrifice this instead. Let's see. We can actually, if we sacrifice that, we should actually be able to move. You can only move one. Alright, this sacrifice was not useful. Let's just put it back. Jump. We could do without jumping, except that we have space constraints. So let's just jump. Okay, and pitch it here. Okay, clean this. Okay, and then mm, put this to here. Jump. Well, this will not be nice. Doing it here. Other way around. Just wanna keep the traces together. Gives that nice looking bus. Okay, so let's clean it up and then mm, all right, all right. So yes, uh, you have to finish route these two guys, and then we will be good. I'll be here. Yep, goes to that point. We clearly got a job. Okay, and then jump. Good, good. Then this one, go through this space, and then let's manage it through this. Oh, good, no jumping. Let's clean this up. All right, so yes, we are gradually finishing up neatly. Right, so right now we're done routing the light session. So what we are left with to do is the connections. Yeah, only left with the connections to the Arduino board. Now, you see that this is not very easy. Okay, actually, this board is not a dense board. Trust me, it can take you days to finish some boards. This board is not dense. It's not dense at all. When there is so much space constraints and size constraint and all that, it can take you days to route a board. So if we're able to do this in 2 hours, well, that would be cool. All right, so let's see. Back here, we have a lot of things to deal with. The signals. Okay, so the buttons and all these things are here. Probably we have to change orientation. This is not gonna be easy to do this. Or we may have to put in more spaces. Let's ungroup this and that. This one is for the lights, the green and the RGB. Right, 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 right. What would be critical here would be spacing. The issues that we have here will mostly be spacing. But still, we gotta route it anyways. So let's start with no, not the potentiometer. Let's start with our interrupt pin. Interrupt pin is coming to this place. Unfortunately, we can't put interrupt anywhere else other than where we've kept it. So okay, let's bring in the signals. They are very important. Let's bring them in. So uh, power is important. So let's just jump this over and push this guys here. So jump and okay, bring it in here. Oh, now look at something. You see, uh, on our GSM module, we have this the signals arranged as RX, RST, RXTX, right? But over here, it's upside down. RST, and if we actually try to do it this way, we are going to do some crossing, right? So what we're going to do is going to change RST and TX, okay? But we have to do that in the schematic, right? So we're just swapping on the Arduino board, just swapping RX and TX. What's happening here? Okay, all right. And then anytime you make any updates, make sure you okay, change it. You recompile or something like that. All right. So now let's see. Push this here and change layer. Good. So that will be TX and then RST will also come in. Move nicely along. See, so now we have them in parallel. That's connected. Then pitch this guy to through this point. And okay, so we need to make some more room, some more space. Okay, okay, so good here. But I think we will still need this thing to move, so let's clean up this. Let's pick it from here. Yep, right, right. Okay, great, 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 great. Yeah. So we sorted out these guys. That's good. The buzzer. Oh yeah, we can actually under the buzzer. In fact, let's jump in it. Nope. Uh, from base top. And we squeeze some more space. Yes. Okay, but don't forget that we don't put this directly. It has to go to the bottom. So we change that and then we rock. Okay, good. I think we can do some cleanup over here. Yeah. Okay, good. Good. That's good so far. We're done with that side. Now these signals, very crucial, very crucial, very crucial. But we're gonna have some challenge moving there. Hmm. Gonna have some challenge moving it. Horizontally, that wouldn't be ideal. Or can I give that a try? Okay, so let's rotate it. So it's rotate this. Let me group it. Do the same for this. Hmm, okay. Yeah, we still kind of not have a lot of spaces. Still don't have that. Still don't have space. Okay. Hmm. We still don't have space. Anyways, button 1, button 2, button 3. I think, can we bring this one down here? Yep, I think this should do down here. This will be good down here. Yeah, yeah, this will be good down here. This will be good down here. That will get to route it directly. Route it directly. Okay, so this is what I'm going to do. Yeah, parallel. Okay, so let's try. Move. What's the size? 1. Okay. Move here. Move. Or wait. We can save some space first. shift this to this point and then do that. Okay, so that we don't have to cross this while routing this. All were to be this easy. Exactly. So yes, we may have to resort to putting spaces in between. Now, if we were routing for a professional PCB house, this wouldn't have been a problem because now in that case, I could make what do you call it? I could make the traces thinner, but here there is a minimum we can go, and that's if we do thinner than that, we would begin to have issues with our board. So yeah, usually it is much work doing it this way. So personally, I prefer uh, printing with an actual manufacturer. Okay, so now we have some space in there. Let's see if it gets our work done. Okay, all right. And then let's see, can move. Okay, so we can move this one. Wow, so one problem solved. Now let's line it up with this. Do same thing for that. And for that. Okay, so that saves us here. Now we can route this guy through here to this place, right? Do this, and then, yep, we get a direct access to this guy. No, but before we do that, I think we should also try and put some spaces in between this, else there would be a problem. Let's put some space in here. Okay, and align them and distribute them. Okay, so that now we can start. Uh, Probably let's make them align with this. Yep, and probably that's good. So to here, easy, easy, easy. Clean it up and do the same thing for this guys. Okay, right. The main signals have been connected. DG, new guy. Okay. D2 red. Why do I have two D2 reds? Whoa, there's something not right. Oh, okay, okay. It's actually right. Actually right. So I definitely gotta jump. Jumping is not gonna be easy. So let's from here through here to there. Okay. Do the same thing for here. Okay. Okay, and then oh, this one is a cool chop. So you just gotta tap it from here in there. Okay, gradually, gradually. Now, how do we get this done? Let's see. Pots. Whoa, we already moved. Hmm, this is not gonna be easy. That makes it fun. That makes it fun. Okay, so let's see. Let's see. I need to route this, but I've already crossed this several times. So if I move this in here. Let's see. Let's see. Nope. Start from bottom and change. Okay. Let's see if we're able to do the same for the other stuff. Start from bottom, change. Okay. Right. To here. Change this point and then connect. Okay. And then we are left with the last one. Again, change at this point. Okay, let's push this guys backwards at this point. Yep. Now that is where the oh actually yeah. Can we do something about this? Can actually do something about this. Okay. Hmm. Can actually do so. Let's first finish routing this to this point. Yeah. Now we bring in this guy, make space, routing through here, make space, change him through here. And that's it. Can connect, saving us all the hassle. All right, now let's clean this. Let's clean things up. So, yep, that's. Let's probably do it through here, straighten it. Okay, I think this is good. Probably move this a little bit to the middle. Yeah. Okay. Gradually, gradually. Now, this is the reset button, I guess. So, reset. Oh, this shouldn't be difficult to pull. Change it over here. Move through here. Okay, lock in. Drag it upwards a bit so that we have space to route this. And once we get to this point, let's clean up. Okay, let's clean up later. We can also drag this upwards, move this here, and that's here. Okay. And that should give us space. Change layer and then remove, right? Okay, so let's clean things up. Get rid of this. That, that. Okay, let's. Okay. Okay. All right. So yes, one down, one more to go. Okay. So we have the interrupt pin here. We have the relay here. I think for the relay, we could actually route it from here to here. Yeah, the relay isn't problem. Yep, and we're done. Let's clean this up. Okay. All right. Okay, there is something that needs to be connected here. Mm. All right, when I will come there, we'll make space for it. So relay down. Now the interrupts, definitely we have to route it from here. So this D1 guy, gonna move it through here, change and move it back here so that I can lay it from here. Yep. Okay. Really interrupt pin. Interrupt pin. That's also going to be quite problematic. But there are other important stuff to note. What is this? This is this. Could save some space. Move it through here. Through here. Okay, and instead of jumping in, rather extend this side to this point. Leave it that. And then you can route this through this point. Here. Okay. Now let's clean this up. Yeah. Good. Good. Okay. We can also route this actually. If we want to do that, then sorry, I have to move this backwards and shift this until it has good clearance. And then do that. And do that. Okay. Still not much space. Okay. Could still and move. Yes. Okay. So let's get rid of this. And then move that. Treat it. Move this through. Yep. And move this up. Fix it. And then up. Like that. So we can use this up. Okay. Just some 6 routes and then we are done. This guy, yep, we should be able to, yep, we can do this and then that. We have to jump and go back, settle, and then connect that. Okay, let's clean this up. Good, good. Okay, how many? 1, 2, 3, 4, 5, 6. 6 more routes and out of here. Okay, now red, blue is here. You know something we can do? We can actually hand this in. So we do a crossing. Unfortunately, I can't too far to do that now. So let's see. This is this here. Blue goes to here. We can see last piece shifted to. Can't see enough space. But oh, let's see what we can do. Change layer here and change layer, right? That's also blue that we are blocked, we are blocked. We are locked. We are locked. Okay. That's one thing that we can do is to rearrange this diode, and that's that. Yeah, can rearrange it since we are not constrained on this. Yep. We do this. Okay, we do this. You should be able to route it to okay. Okay, so 5 boots. Okay. Six. Alright, now our interact is handle it later. So what can we do now? Great. That's not gonna be easy. Borrow some space. Good. Borrow some space. So we can push the bed through. Then we still need to grow some space. So let's see how we can put that. Put this here. Three. Wow. Okay. So we can borrow space here and roll out this and see we could. Yes. Fantastic. Okay. That leaves us with one more, which is the blue. Fortunately, this one is not a problem. So for this, just move it through here. Okay. So let's apply our trick. Go to the box settings, change this to complete, and now can route through because it's the clearance that's preventing us. Okay, and that helps us route this. Okay, so the critical stuff are out of the way, and now, so this guy here should be able to route it through this space. Okay, we can make space here, make some space here, and fix this. Okay, and we can now move this to this. Yes. See, see. Okay, okay, okay. We can rather sacrifice this 5 volts instead of passing it through here. Make some space, example here. Alright, we need 5 volts here. Okay. Through here should let's see if we can make some space. Yep. Space is Okay. So we don't have enough space. Okay, then let's just do this. Let's do this and so that should be with our 5 volts so that we can route our interrupts through here, through there, and bring it here. We will have to make some space available. Yeah. And then, yeah, jump one more time. That's not available here, so let's make more space available. Just jump. Okay. Yeah, let me clean up a little bit. Just zoom out the space. Good. Alright. Okay. Now, 2 more to go. These ones, we could actually push this upwards. And then move the first one on the bottom. And actually save some space here. And route this through. Let's see. Routing this through. I'll need some space here. So this, move this down, and jump. Yep. Yeah. Fantastic. One more to go, and then entirely ready. Okay, so one last route, and we are done routing. Oh, we already used 2 hours 20 minutes. Let's move this. There is something here that needs to go to it. This time I'm moving this here. Can we optimize and save some space here? Sure. Good. good, 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 good. Can we through here, through the, we can jump, yes, I think, okay, we can actually do that. Move it. So let's see. Hmm. Shift you upwards a bit. Okay. Trying to make space for the last route and straighten this. Okay. So now move this, move this, and move that through here, through there, and jump over here. Once we jump, move up like that, change layer, and that is it. Our last route. Okay, so I think that is all. Don't worry, there is a way to check that you've actually routed everything. I'll show you very soon. Okay. Yes, I mean, this is not something I'm very proud of because you guys should take a second look at it. I can optimize a lot, but I said we don't have much time and we just need something for a lecture. Okay, so I'm copy with this. So after routing your board, you may want to fix some issues. Like if you come to tools, you can do something like clean up the serious refill. So delete tracks connecting different nets, delete redundant layers, delete layers connected only to one layer. Okay, delete layers only inside paths. Okay, delete that and it's good. Let's see one more thing. Remove unused parts. One more thing. Repair clean up graphics. Okay, one more thing. Repair board. No problems. Okay. Now the last thing you need to run here is design rule checker. Definitely, I know we would conflict some design rules, but that's okay because I did it intentionally. So we check in for oops. So you can see that most of our errors, the clearance violation, clearance violation, clearance violation, right? So it means that we have issues and most of our errors, clearance violation. Okay, all of them so far. One thing you should always check for is unconnected items. See, we have zero unconnected items. That means that every net has been connected. Then schematic parity. Is there a difference between what you have in your PCB and what you have in your schematic? Okay, if there is any difference, then it will raise an error that way. So far as these two are off, I'm good. But these guys actually, I can turn most of it off by setting a lower clearance. See, as we are right now, we are using what 0.8, but so if I set something like 6 mm, see what happens. If I run this again, most of it will go. You get it? So you only have up to what 3. Okay. But that is not actually something. Oh, and let's check the warnings. Solar claim matter. These things are also not necessary for us because we are not even going to print the solar mask anyway, and the silk screens we are just going to print the copper, and so all these are not necessary for us. But then, in my design, I need a clearance of 1 to be between the copper cores and almost everything else. Okay, unless otherwise stated, so I'll put 1 there. And so now if I run this again, I'll probably get 2000 errors.
Yeah, so 221, and all these all those errors will be clearance violations, okay, which is okay. So delete all markers. All right, so let's copper fill and then bring back our press H. So this is how the top layer looks like, okay, and this is the bottom layer. Now take note that we are technically supposed to join the two grounds together. Okay, so as you can see, all this place the ground is broken. Okay, so we have to fix that immediately. How do we fix that? Can fix that by pushing some ground vias, deliberately pushing vias through. Okay, now because this is not going to be printed by a machine, I would limit the number of vias I would want to push. So let me push 3 by 2 at this space. Okay. If it is a machine that was going to do it, then I could do a lot of VS. We call this uh, ground stitching. Okay. So I'm stitching the two grounds together. So I'm going to push a couple of VS through to connect. So here, wow, I can't also be doing so many of them. So okay, let's just go 2 2. Okay, so now if I refill, see that there should be the blue is filling up. Okay, yeah, it means that everything is going accordingly. I don't need some in here. Good, over here, yeah, this place can do with some ground views. Good, this place can do. Yes, so let me just put a couple them at different places. Here, put my this two here, in the middle here too. Yeah, let's put some here. Take notes. If you are going to solder this by hand, you don't want to push so much. Okay. Make sure you don't put any here. This is the AC side, right? So when you are pushing a stitch, make sure it is not going to intersect with any uh, route or trace. Okay, so this place would can do with a stitch. Okay. Mm, what about here? Yes, this place can do with a stitch. Okay. I think we good. This place there is no need for a ground, so I'm gonna leave it like that. Okay, there is yeah. This place can actually do with a ground stitch. Okay, and let me push some here, but let me add 2 more for proper grounding. Okay. All right. So I think we are good uh, to go. Let me push some two more here. Hmm. Linear ground here. Okay. Great. I think it's okay. It's okay. Now let's run DRC and make sure we don't have any unconnected signals. Right, unconnected items are 0. That is good. That is good. Okay, so we delete all markers. And let's take a look at the 3D view. All right, I think we've done a good job. I hate this blue board. Let's change it. Okay. All right, so this is what we have done. It's time to print it out and develop it physically. Okay. Okay, so we'll do that in the next session. We'll do that in the next session. Can I put some text on this? I'll break it down. Let's see if I could put some text on them. If I want to put some text on it, would that be possible? No, 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 no. That will not be possible. So I'll just leave it like that. I just leave it like that. I just leave it like that. Okay, so this brings us to the end of the third of class session. What we're going to do right now is to move to the lab and then print everything out and look at how to build or etch the board. After that, we will have the last session, which will be soldering the components onto the board. So we have two more sessions to end. I'm hoping we can finish before it is 6 o'clock. We still have about 4 hours. So let's see what we can do. Once again, thank you for watching. Don't forget to share, like, and leave your comments below. Give us a thumb up if you like this video and subscribe to our channel. This is Prof, and thank you for watching.